hydrothermal explosion rocks Yellowstone.
But yeah, that eruption proving spectacular and terrifying all at the same time. Scientists at Yellowstone National Park telling us this was a random event happening without warning.
The trails in Yellowstone National Park's Biscuit Basin have long been a peaceful place to stroll and admire the geysers and hydrothermal pools that draw thousands of tourists each year.
Beneath the endless blue sweep of Wyoming's sky, in the storied wilds of Yellowstone National Park, a wisp of steam has changed everything. For some, it's barely a fleeting sight, a silver column curling skyward beyond a lonely patch of asphalt. For geologists, volcanologists, and those who know the tremors and whispers of the earth, it's something far more significant, a phenomenon for investigation, a potential signal from the restless underground, a question, a story with no ending yet. It began on a morning cloaked in late summer chill, as dawn gilded the bison-dappled meadows and tourists rumbled toward the next viewpoint. Among the familiar geyser basins and ancient pines, an unfamiliar sight drew attention, a robust plume of steam, rising not from an old vent or time-worn pool, but from uncharted ground near the Roadside Springs thermal area. In a place famous for its geothermal wonders, this subtle difference was anything but trivial. By afternoon, word had ricocheted through the scientific community. The U.S. Geological Survey confirmed it. A brand new hydrothermal vent had formed, releasing hot water and vapor into the Rocky Mountain air. Its temperature, a measured 171 degrees Fahrenheit, precisely documented by geologists monitoring the feature. Roadside Springs has always been a patchwork of intrigue, a collection of spatially distinct thermal areas flickering with life beneath the surface. But this was something new, and as geologists hastily convened, questions began stacking up faster than answers. Why here? Why now? And most importantly, what does this rising steam mean for the restless system below Yellowstone's crust? Is it just another exhale from Earth's hidden engine, or the opening sentence in a much larger story? An unfamiliar plume in familiar terrain. The Roadside Springs thermal area might not grace glossy postcards like Old Faithful, but to researchers and geologists, it's one of Yellowstone's lesser-known yet highly dynamic regions. A patchwork of boiling soil, warm runoff, and hissing vents set just far enough from the tourist crowds to go largely unnoticed. But beneath its modest appearance lies a volatile, ever-changing system that demands constant attention. In August 2024, a sharp-eyed geologist walking the area on a routine survey noticed something unusual, a new, forceful plume of steam rising from a previously quiet section of ground. Initially dismissed as a fleeting change in wind or temperature, the plume returned with intensity the following morning, glowing faintly in the dawn light, like a column of breath in cold air. This wasn't a reawakened vent or a harmless vapor pocket. It was something entirely new. Within hours, USGS scientists deployed field teams to the site. The new vent, approximately 20 feet from the nearest documented feature, was confirmed using thermal imaging, infrared scanning, and direct surface temperature readings. Ground surrounding the vent had reached well above 180 degrees Fahrenheit, 82 degrees Celsius, and the soil emitted measurable levels of hydrogen sulfide and carbon dioxide, classic markers of hydrothermal activity. But what stood out most was the vent's persistence. Over the following weeks, the plume did not diminish. Instead, it stabilized, suggesting a more permanent reconfiguration of the hydrothermal plumbing system below. Subsurface sensors detected minor ground uplift in the surrounding area, just a few centimeters, but consistent with fluid pressure shifts beneath the surface. The region's seismic data, too, showed a slight increase in microquake activity localized near Roadside Springs, hinting that pressure might be rearranging the underground network of fractures. What caused this new release? Several theories have emerged. One posits that a minor tectonic shift allowed superheated water, previously trapped, to escape along a freshly opened crack. Another suggests a buildup of pressurized gas deep in the hydrothermal system, suddenly given a release valve. Either way, the event adds weight to a growing realization. Yellowstone's plumbing is always in motion. Unlike catastrophic eruptions, these smaller, seemingly mundane changes are windows into the system's heartbeat, reminders that the volcanic forces beneath Yellowstone are not dormant, just restrained. The vent continues to puff, and scientists continue to watch, quietly, intently, and without assumption. Steam in the morning, nature's signal flare. Yellowstone presents spectacle with reliable regularity. Geysers erupt with choreographed timing. Mud pots bubble in rhythmic pulses. Fumaroles hiss as if the earth itself is breathing. But this was different. It didn't fit the schedule. It wasn't on the maps. It wasn't supposed to happen, at least not here, and not now. By late 2024, as the high season began to taper and a sharper chill edged the air, the new vent at Roadside Springs became hard to ignore. On cold mornings, its steam plume cut starkly against the sky, visible even from passing cars on the nearby highway. Tourists pulled over, drawn not just by curiosity, but by a subtle tension in the air. The plume didn't look theatrical. It looked real, unfiltered, like a message rising straight from the Earth's core. Sensors recorded elevated hydrogen sulfide and carbon dioxide levels, and vegetation in the vent's path showed signs of thermal stress. Leaves curled, soil darkened. This wasn't Yellowstone's first spontaneous vent, far from it. But what stood out was the duration and location. The last major hydrothermal shift in the Roadside Springs vicinity had occurred some 20 years prior, resolving quickly and without ongoing activity. This one, however, persisted for weeks, then months. Each sunrise revealed a defiant plume, snaking upward in silence. The vent reawakened a stretch of land once considered quiet, a patch that had gone unnoticed in geological briefings and tourist brochures alike. It rewrote assumptions. To scientists, the emergence served as both reminder and riddle. Yellowstone's landscape is not just beautiful, it is alive. Its surface the thin crust over a restless engine. No timetable governs the shifting of underground fluids or the rupture of thermal seams. To residents and rangers alike, the message was familiar. You are standing on a system, not a stage, and it moves, even when no one is watching. Origins in the deep, anatomy of a thermal awakening. To casual visitors, Yellowstone is a theater of surface wonders, spectacular and ever-changing. To geologists, it's a thin, quaking crust stretched atop one of the planet's largest magmatic systems. Here, interactions between ancient rock and rising heat generate a spectrum of thermal phenomena, from bubbling mud pots to roaring geysers and hissing fumaroles, each one shaped by invisible architecture below. The new steam vent at Roadside Springs is no exception. It is a visible symptom of deeper processes still poorly understood. Beneath Yellowstone, rainwater and snowmelt seep downward through fractured, porous volcanic rock, descending layer by layer into Earth's crust. As it travels, this water meets zones of increasing heat, particularly near the still warm remnants of magmatic activity lodged in the park's subterranean heart. This is not the magma itself, but its ghost, residual heat trapped in stone, slowly radiating upward through a living geology. Superheated and mineral-rich, the groundwater undergoes transformation. No longer just rain, it becomes a pressurized fluid, seeking escape. And when fractures or weak seams open, perhaps triggered by minor earthquakes, seasonal expansion and contraction, or even subtle ground shifting, the pressurized water bursts upward, emerging in an eruption of steam and boiling liquid. As fall advanced, scientists noted the vent's heat remained constant, despite surface temperatures dipping below freezing. There was no sign of closure, no weakening of steam, no collapse of the vent's narrow channel. Instead, the feature persisted, quietly dramatic, a reminder that Yellowstone's most significant movements often begin with the smallest shifts. Could this be only the beginning of continued change at Roadside Springs? The region's geothermal history says yes. What lies beneath is never still. Eyes on the steam, science in rapid response. When Yellowstone shifts, scientists respond. The emergence of a new vent at Roadside Springs in August 2024 triggered an immediate mobilization of monitoring teams from the U.S. Geological Survey, USGS, the Yellowstone Volcano Observatory, and park geoscientists. As the morning steam cut against the crisp mountain air, the race to understand its origins began. Thermal sensors were deployed first, scanning for surface anomalies. GPS units tracked micromovements in the soil, critical for identifying ground deformation that might accompany deeper shifts. Data loggers were placed around the vent's perimeter to record temperature fluctuations and gas emissions over time, helping to distinguish between a transient release and a long-term development. With each new data point, scientists layered present observations atop Yellowstone's deep monitoring archive. Roadside Springs has a sporadic history, known for minor thermal episodes, but rarely sustained features. The most recent comparable emergence had occurred 2 decades earlier, quickly disappearing after a brief flurry of activity. This time, the vent persisted through the changing seasons. Researchers cross-referenced regional seismicity and ground deformation using satellite-based INSAR and continuous GPS networks. While minor quakes had occurred nearby, none exceeded the norm for hydrothermal zones. Similarly, no significant uplift or subsidence had been detected that would suggest broader magmatic activity. The early consensus, a hydrothermal reactivation, not a volcanic red flag. Still, the vent's location, so close to the roadway, raised safety concern. Communication protocols kicked in. Park rangers rerouted hiking traffic. Warning signs were posted. Updates went out to tribal partners, safety officers, and nearby facilities. The questions persist. Is this part of a broader realignment of subsurface water pathways, or an isolated episode in Yellowstone's restless hydrothermal puzzle? Only time and continued monitoring will tell. Contexts of change. The long memory of Roadside Springs. Though some may be surprised by the vent's emergence, Yellowstone's land has witnessed repeated cycles of change far greater than the birth or death of a single feature. The park's history includes collapsed calderas, lifted basins, and redirected rivers, a record of immense transformations over eons. Roadside Springs in particular is known for its unpredictability. About 20 years ago, a similar vent appeared and then closed quietly. Across the area, small features have come and gone, governed by shifts in subsurface flow, deposition of minerals, and dynamic thermal balances. In Yellowstone, permanence is always provisional. Layer upon layer, the region archives its own record. Altered volcanic glass, mineral crusts, and patchworks of clay and grass document countless previous thermal events. Each cycle, surface rupture, deposition, closure, leaves visible and chemical evidence, contributing to a palimpsest readable by scientists with the right tools. This new vent is both a disruption and a continuation, part of an ongoing dialogue in which the deep geology periodically announces itself. Every new hydrothermal formation is a chance to test past theories on fluid movement, volcanic influence, and fault line dynamics. To most visitors, this steam plume blends into the landscape's pageantry of geysers and springs. But to those who study Yellowstone, such features are vital clues, offering glimpses into the park's living systems and their persistent, sometimes unpredictable change. Will this feature become another brief episode in an ever-evolving story, or signal a more persistent transformation? Hazards and warnings. The cost of Yellowstone's magic. Each year, Yellowstone draws millions for its beauty, but its appeal is inseparable from geologic hazards. The new vent at Roadside Springs captivates scientists, but to park officials, it's also a source of warranted caution. Hydrothermal features can develop quickly, and areas considered safe one year may become dangerous the next. The ground in thermal areas is often a thin crust, easily broken, with boiling water and destabilized rock just beneath. New hydrothermal features present unpredictable risks for anyone who steps off established trails. After the vent's discovery in August 2024, rangers and scientists moved to safeguard visitors. Signs warned of unstable ground. Patrols ensured that the curious kept their distance. Reports and stories from past decades of shoes melting on ground, of near misses and serious burns, reinforced the need for respect at a site continually in flux. Risks are not limited to surface hazards. New vents are closely analyzed for signs that could precede bigger events: augmented thermal activity, unexpected geyser changes, or rare hydrothermal explosions. Although the new Roadside Springs vent showed no evidence of magmatic unrest or significant ground deformation, continuous monitoring was established as prudent policy. The scientists' message is measured. No current indication of magmatic unrest, they affirmed, yet sustained vigilance is essential in Yellowstone, where long-term patterns can change and have changed with little warning. Is this new vent a routine reminder of nature's unpredictability, or the hint of deeper changes brewing within the system? Patterns and the past, reading the signs beneath the steam. Scientists search for patterns, leveraging decades of data to contextualize each new hydrothermal event. In Yellowstone, every notable development is a potential clue to broader geologic or hydrologic processes. Roadside Springs serves as a living laboratory. Its collection of thermal sites provides abundant opportunities to monitor change. Some features have appeared and vanished with little fanfare. Others have become enduring landmarks. Every new data set helps construct Yellowstone's evolving timeline. Past changes in the area have been linked, sometimes in retrospect, to subsurface water flow, background seismicity, or minor ground uplift. Analysis of current and historical data may reveal whether the 2024 vent corresponds with similar patterns: an especially heavy spring thaw, small local earthquakes, or gradual groundwater movement. At the system's heart, the giant caldera serves as a constant reminder of deeper connections. Hydrothermal features at the surface reflect an ongoing conversation between Yellowstone's crust and its hidden sources of heat. Does the 2024 feature echo events of the past, or suggest something new for the future? Only further study and long-term monitoring will show whether this vent is a solitary outburst or an indicator of broader changes. Tomorrow's Yellowstone. What's next as the steam rises? It's a breathtaking thing. To witness the planet's decision-making, a new hydrothermal vent appears, marking communication between miles-deep geology and the visible world. As 2024 turned to winter, the new vent at Roadside Springs held its place, its plume rising into the cold and drawing attention from all corners. Yellowstone, immutable yet constantly shifting, reminded all who watched that its transformation is ongoing and unpredictable. For scientists, the work continues, expanding the monitoring network, reviewing thermal images, studying groundwater shifts, and correlating seismic activity with surface features. Every new measurement feeds the longer narrative: Yellowstone as a system of perpetual negotiation between surface and deep interior. For visitors and viewers everywhere, the lesson is one of humility. Yellowstone's story is not linear, but cyclical and intricate. Each new vent is both a sign and a lesson that the earth beneath our feet is active, that wonder and risk are kindred, and that certainty will always be elusive here. One thing is certain: the earth beneath Yellowstone is ever in conversation with itself, its messages rising in steam for all to see and consider. If you want updates on Yellowstone's hidden forces, like this video. Hit subscribe to stay close as new wonders and warnings emerge from the world's most famous volcanic landscape. And in the comments, let us know, do you see this as the next great mystery or just the Earth, reminding us of its restless voice. Thanks for watching. In Yellowstone, the only constant is transformation.